Hey all, this is Raj here. Nice having you all out here today. It's been fun so far. Been learning a lot over a couple of the sessions today. It's been fun. Today we are here. I'm again Raj from AgileIss. Just rolling. We are primarily a BA analytics solutions company. We help companies with putting their BA analytics with big data solutions together, primarily focused in Southern California region. So our goal is mainly to make big data meaningful for all enterprises. Currently, big data is pretty much, there are a few enterprises, technology-based industry, who are using big data because they have to use big data. But big data is something which does not make sense for everyone. So our goal is to make big data meaningful for all the large enterprises, mid and large enterprises. So today, during my presentation, I have really two goals. The first goal is to make sure big data is not a solution only for the selected few enterprises, to convince on that. Big data through the enterprise data lake solution, which we will be diving in deep and talking more today, is mainstream. I think data lake solution is going to slowly in the next few years going to become a standard stack in all enterprises, in all enterprise solutions. So that's what we're going to talk about. Enterprise data lake solution is a lot more agile, nimble, and it's significantly economical and powerful. And scalability wise, it's pretty much scale to whatever level you want. The second goal of mine today is enterprise data lake. So the enterprise BI solution currently is our enterprise data solution. 100% is pretty much taken up by databases, traditional RDBMS, SQL databases. The trend is going to be over the next few years, through this decade, is going to be the No-SQL is going to become a significant part of that. So No-SQL, the Hadoop-based No-SQL and other related technologies is going to take the market share from an enterprise solutioning point of view, from the traditional SQL, Oracle, and those kind of traditional databases, because and they fit together. It's not that it's complete replacement. Each have their own place, and that's what we're going to talk about. How they can work very well with each other, and then they add a lot more value together than independently. So why for last 20 years. We all know, we have heard about enterprise data warehouse. Enterprise data warehouse, the goal of it being, build a data warehouse, bring all my enterprise data, my marketing data, my supply chain data, everything into one, and then so I can analyze. And we all know that, who has worked in that long enough, that never happens. It never happens for the reason. So if you just go and Google why enterprise data warehouse failed, pretty much you'll get reasons like this. The data warehouse is way too expensive, it is way too slow, it takes too long for me to get any data into my systems. It has to go through the standard SDLC process. Where's the requirement gathering? It takes too long for requirement gathering, and then do the development and all that stuff. So that's why EDW, many companies started large enterprises, but it never, maybe they would come to a point, they would build it, but very soon it would be out of sync because it can never catch up to the speed of business evolving. New business models comes in, new data sets come in, and you can never evolve a system fast enough to catch up on all the changes going on. So, the key difference between EDW data mart and EDL is in any EDW and data mart, you define the data, you tell what is the data you need in the requirement gathering process, and then that's the data you take into your system. You map it, you massage it, and you process it and load it. That is the traditional EDW. There is no system where you just take all the data and suck it into the system. It's not possible. You have to do ETL, processing, and then load it into your EDW data mart. This is where the enterprise data lake, Hadoop-based enterprise data lake, is significantly different. It's significantly different because in enterprise data lake, there is no limitation. You put the data as is, whatever comes in, you put it there, and it stays there. There is no ETL needed, there is no transformation needed, and there is no database needed. So the moment the data is in your data lake, it is available for access. Within like 2 minutes, it's available for access. This is a significant shift on how we think about data and using the data through the traditional database systems to the enterprise data lake. And obviously, enterprise data lake retains all data. You don't need to choose what you want or what you don't want. So here are all the things with the enterprise data lake. Because it's Hadoop based, it comes with a commodity hardware. It's significantly cheaper. Most of the software is open source based, so it's not expensive. You can get enterprise managed management. So they are available as service too. So it's significantly cheaper than a traditional databases, buying a traditional databases, and then the hardware associated with that and all that stuff. This is, as I mentioned, all data is in your data lake. There is no need for ETL to put the data in your data lake. Significantly expensive. And the moment it is there in your data lake, there is no latency. There is absolutely no latency in a data lake solution. Whereas in a database, there is always a latency. There is a latency in the development process, and then there is a latency in moving your data in whatever frequency it is. For people, how many of you are familiar with data lake? How many of you have implemented or familiar with data lake? Not many, because it's a new concept. The data lake is, here are some of the, if you Google it, the standard things that you get from Wiki Dictionary. It's massive accessible repository data in its original state, and stored in a commodity hardware. And then it holds the data in the native format, so there is no transformation. Whatever is the native format it came, the data resides in that. So the term data lake was coined by Pentaho CEO James Dixon a couple of years ago, and since then it has been caught up. A little bit more into the details of how you differentiate a data lake from a traditional data warehouse or a data mart. So if you consider a data lake is complete reservoir of data, all data coming in, there is no processing, there is no filtering, there is no cleaning. That's like the lake. Your data marts or your any database system is like the bottled water. You're processing it, you're transforming it, and then store it. So trying to transform all your data and putting it into the bottle, it's expensive, time consuming. It's not the most effective way of doing it. High level logical diagram of how the data lake works. So you have the data lake, and then pretty much it stays in the data lake. Your data scientists can go and do the analytics in the data lake. It can be also your ODS and the archive for some audit request or something like that. Comes in. The data is always there in your data lake. It's not like a cold archive where once it's gone for away. You have to pull it from the tapes. In the data lake, it's always residing. So you can always access through your Hive or Spark through your Hadoop ecosystem. And then you ETL only the data you need from your data lake into your data marts. So this is the high-level overview of how a data lake operates. So what is a data lake? Is it a product? No, a data lake is just an architecture. It's an architecture based on primarily the Hadoop-based data lake becoming your foundation of your enterprise database systems. And then for your primarily the analytics and BI and archive system. And then you have your databases. How many of our database enterprise data systems sitting above the Hadoop-based data lake? That's the key difference in the architecture. So far, the way we had is everything was in database. Everything was in database. That's the only way we had. So you could be using some data once in a quarter in a year. It could be sitting there and spinning 7/24, 365 days a year, even though it's never been accessed. Database solves that problem. So you keep those data when you need it, you can analyze it. If you need it for high performance, you can do a quick ETL, Hadoop-based ETL Python, and then you can load it into your database and it's immediately available. Even without doing that through your Hive, it is always available for your analysis. The data lake solution, you will hear some of the major vendors like Teradata, IBM, they are all coming with products called Data Hub. Data Hub is nothing but, it's pretty much like a data lake, but they are packaging it along with their database. So they are taking the data lake, and then they are taking their database, which they have been always used to selling, and they package it, and that's what is Data Hub. So this would be the standard architecture, how the data lake would look like. You have the standard enterprise systems on your left. You move all your data into your data lake. Once they're in your data lake, then basically you'll see two streams going on. The first stream being, you can do the traditional ETL. That will be the store reservoir for all your traditional ETL to come and grab that data, and then you can load it into data marts and then available for your analytics and reporting tools. You can also use them through your Hadoop-based data pipeline, big data ETL tools, and then load them into your data marts. So that is loading into the data mart part. Another part is direct access. You can directly use the Spark or Hive or Presto or any of these big data tools to do a direct analytics on your data lake. So you have data available in both means. The next picture, I'm just stacking it in another way so that you can visualize. So you have your enterprise system, then the bedrock of your enterprise data is your data lake. And then you stack your databases above. So then it is available for, it is kind of the source system for all the systems in your organization for exchanging the data. And it is also the foundation analytics. And then there is absolutely no loss of data. Everything you have in its raw original format is available. One of the main reasons we always load the data into the database is because of performance. So we put the surrogate keys and blah, blah, all that stuff. We do it so that it performs higher. With the Hadoop, you can use the natural keys. And you can throw the power, the horsepower that it needs, and you can get the data out of it. So that's not a problem too. This one, so the previous one I showed is kind of an on-prem architecture. So this can be in your storage systems within your on-prem, EMC or whatever is your storage system. That is the data lake can be there. And this one is the lake on the cloud. So you can build your data lake on cloud. You can go to Amazon. It's the data lake is on S3. You can go to Google Cloud. So you go and store all your data. You build your lake on the cloud, and then if your enterprise BI system is on cloud, then everything is running on cloud. Or you can move it from your enterprise system. So here what we are doing is, you will have the enterprise systems. From your enterprise systems, all the data is flowing into the data lake. And then in the data lake, you can take it and load it into your Amazon Redshift databases. And you can load them through data pipeline, or you can use your traditional Informatica or SSIS tools if you want. Or you can use both for high performance and some complex transformation. And then from there, you can load your data marts from your cloud to on-prem too. So you can use them in multiple combinations, whichever. So you can build either a cloud-only strategy, or you can use a hybrid strategy where you're using both cloud and on-prem. So your EDL, enterprise data lake, can be following. It can be a central data enterprise data repository. Some of you might be familiar with the ODS and the data hub. It can be your staging area for all your data sources. It's a warm data archive and vault for your entire enterprise. And you can, I've seen organizations now, they are doing a simple star schema on Hadoop. It works with the enterprise tools. So completely on Hadoop. So you can do that too. So your EDL can service following people. Anyone who are everything, who are impatient, they want the data right now, immediately, once the file is in. They cannot complain that they didn't get access to something when the file is not there. That's somebody's problem. The moment the file is in, it's available for their access. They cannot complain about it anymore. Because there is absolutely no ETL, there is no report development, anything. They can go in, you can give them the tools. They can, as long as they know how to use those tools, the data is immediately available for them. And then, from a cost perspective, from a value perspective, it's significantly cheaper than storing in your traditional databases all your data. So who are all supporting data lake and working in data lake? Some of these people actually, they would, they may not call it data lake because it's an architecture, and what is there for them to talk about the architecture, because they are in the product companies in the process of selling product, they would call it data hub. So they may not, either they call it data lake, or they would their data calls it Hortonworks call it data lake. There are a few others who would call it data hub, but pretty much they're all working on data lake architecture. So really, I think every large enterprise, they should use data lake architecture. So this is where, primarily one of the things is people thought Hadoop is only for people who are having petabytes, terabytes, hundreds of terabytes or 200 terabytes. There is another great value proposition that Hadoop gives that many people don't understand. Hadoop gives a solution for you guys to do processing and analytics without ETL. Anytime the data is available. So that is another functionality of the Hadoop architecture that gives. You don't need to have 500 terabytes for that. You have 10 terabytes. If you have to do ETL mapping and you have to put the requirement document, if you have to take it, if you have to process it, it's a 3-month project, it's a 6-month project. With Hadoop, you can give the query to the user tomorrow and say, okay, go and get what you want. It's a different value proposition that offers. Many people don't talk about it, and the data could be small, but it gives completely the flexibility and the speed for accessing the data. Speed in the ways of not how fast you process it. That's one part of it. There is no waiting time. There is no development time. Nothing. The data is always available for access. That's another significant value that Hadoop offers. Many people don't talk about it. Many people don't understand about it. That's what is important. So I think it's a value proposition all organizations need to consider, where they put Hadoop under their enterprise data as the foundation of their enterprise data. My last slide, people tell EDW and Hadoop is apples and oranges. You put them together, they'll make a great pie. It's a lot more value proposition. Any questions? All right, thank you. No, you just see, so you just need to have a index. So you need to know what data goes where. So you need to create the folder structure. There is some minimal processing so that it's formatted so that it can be easily read. That's all you need to do. But once that's more like setting up a standard. When you create a database, you say like, this should be an integer and this should be a varchar. It's that kind of standard. Once you set that standard, and then you say if it's a product data, it has to go to product area, and then that's just setting a standard. Once you set the standard, automatically things flow in there. So that's the only effort you have to put it in building the data lake. You put that standard, then the data goes into that respective area. The moment it goes to that respective area, then everybody knows where to go, and then they go and push the data. So there is no additional processing needed after that. Anyone else?